In today's video, we are going to be looking at solving for the different sides of a right triangle. To solve for the sides, we're going to think about those three trig relationships we looked at: sine, cosine, and tangent. In number one, I have three pieces of information. One, I got an angle 35. That means that's going to be my reference angle. I look at x. I think about x's relationship to 35. Well, x is going to be opposite of 35. And 12, well, 12 is opposite the right angle, which makes 12 the hypotenuse. So I want to think about sine, cosine, and tangent, and I want to think about which of my trig functions relates the opposite and the hypotenuse together. And that's going to be the sine. So remember, sine of theta is equal to the opposite over the hypotenuse. So in this case, our angle, or our theta, our reference angle, is 35. The sine of our angle is the opposite side, which is x, over the hypotenuse, which is 12. So this is the equation I would set up to solve for x. We go on to number 2. Number 2, 10 is my reference angle. I look at x, I look at 18. 18 is opposite of the angle. X is adjacent. So we think about which trig function is going to relate opposite and adjacent. That is tangent. Its tangent of theta is equal to the opposite over the adjacent. So in this case, that angle that we're referencing is the 10-degree angle. The opposite side is 18. The adjacent side is our x. So this would be the equation we would set up to solve for x. And number 3, here's our reference angle of 55. X is the adjacent side. 32 is across from that 90-degree angle, making it the hypotenuse. So we think about which trig function relates adjacent hypotenuse. That is cosine. Cosine of theta is the adjacent side over the hypotenuse. So in this case, the angle is 55. The adjacent side is x, and the hypotenuse is 32. Alright, so now that we know how to set up the equation, let's see how to solve for x. When I look at number 4, I've got cosine of my angle 38 is equal to x over 10. So just similar to our setups that we just did. I want to get x by itself. Right now it's x divided by 10. So to move it, I do the opposite operation. So instead of dividing by 10, I'm going to multiply both sides by 10. 10 divided by 10 cancels, so we've got 10 times the cosine of 38 is equal to x. And yes, we normally write the x first, so x is equal to 10 times the cosine of 38. All right, you're going to need your calculators out now. So if you don't have your calculators out, go ahead and press pause and get your calculator out. All right, so the first thing that we want to do is we want to make sure that our calculator is in degree mode. So if we look at the top, we've got the y equals. We've got second, next to second is mode. We hit mode, and we want to make sure that degree mode is highlighted. So if you look at mine right now, it says normal float, and it actually says radian, and radian is not what we want. We want degree. So I arrow down, I put my cursor over degree, I hit enter, and it's going to change it from radian mode to degree mode. So I make sure that my calculator is in degree mode. Very important, because if your calculator is not in degree mode, every single question is going to be wrong. So I go back to my home screen, so I hit second mode, quit. I went 10 times the cosine of 38. So the cosine, if you look in your calculator, towards the middle, you see sine, cosine, tangent. I went 10 times the cosine, and it opens up telling me to put the angle there. So 10 times the cosine of the angle 38, and we're going to get that x is about, and we're going to round to the nearest tenth, so that's going to be 7.9. We go to the next one. We've got sine of 70 is equal to 20 divided by x. So I want to get x by itself. I'm dividing by x, so I multiply by x on both sides. Those x's cancel. We've got x times the sine of 70 is equal to 20. I still need x by itself, so now since it's x times the sine of 70, I divide both sides by the sine of 70. and we get x is equal to 20 divided by the sine of 70. So we go back to our calculator. We've got 20 divided by the sine of 70. We hit enter. Again, rounding to the nearest tenth, we get x is about 21.3. So as we look at both of these problems, one pattern that you're going to see, if x is on top of your setup, you're going to multiply your two pieces. If you are dividing by x, you divide to find x. So you just switch the x in the sine of 70's position. You want to make sure that you can solve both of those setups. So putting it all together here, we've got our triangle. When we have connecting triangles like this, we want to make sure that we keep them separate. We are having that connecting piece, but I want to make sure that I see that I have two separate triangles here. So we want to solve for x and y. If I look at my pink triangle, I can't start there because the only thing I know is the 50. I don't know the x, I don't know the y. So I'm going to start over on the green triangle. I've got the 25-degree angle. X is opposite, 10 is adjacent. So the trig function that relates opposite over adjacent is tangent. So it's always tangent of the reference angle, which in this case is 25, is equal to the opposite side of x over the adjacent side of 10. Since x is on top, I'm just going to multiply. So x is equal to 10 times the tangent of 25. We talked about how to put that into our calculator. And we get x is going to be about 4.7. Now that right there is the connecting piece. Now that I know that this x is 4.7, I can go to the next triangle and I can use that 50 reference angle. This is opposite, this is the hypotenuse. So I think about the trig function that relates opposite and hypotenuse, which is sine. So it's sine of our reference angle of 50 is equal to the opposite side of 4.7 over the hypotenuse of y. Since I'm dividing by my variable to solve, it's y is equal to 4.7 divided by sine of 50. I just switch out the y and the sine for 50. When we divide that, rounding to the nearest tenth, we get y is about 6.1. All right, our last one, a little bit harder. We think things that we've learned throughout the year are going to continue to come up. We see the most important thing we see here is that this side is congruent to this side, which makes it an isosceles triangle, which means that our base angles are congruent as well. When we have an isosceles triangle and we drop down the altitude, we know that the altitude is going to create those right angles. Because it's isosceles, we learned that the altitude is also going to split the base into two congruent pieces. Since this is 36, we know that this is 36 as well. Again, because it's an isosceles triangle. What I want to do is I want to find this bottom portion. It's split into two equal pieces, which means if this is A, then this is A. You can use whatever variable you want. So if I use my angle of 48, this A, just looking at half of my triangle here, A is going to be the adjacent side. 36 is opposite that right angle, so that's going to be the hypotenuse. So when I set up my equation, it's cosine of my reference angle of 48 is equal to the adjacent side, which is A, over the hypotenuse, which is 36. Since A is on top, I just multiply. So A is equal to 36 times the cosine of 48. We plug that right into our calculator and we find A is about 24.1. Now our job here is to find x. X is found by two of those. So x is equal to 2 times 24.1. So x is going to be about 48.2. Alright, that was your last problem for your video on solving for the side lengths.